Hello there guys, welcome back to another epic maths video. In this video, we're taking another look at multiplying matrices together, but this time we're looking at multiplying more complicated matrices. So last time we only looked at 2 by 2 matrices. If you've not seen that video, go and check it out. The link is in the description. That's going to show you how to multiply 2 by 2 matrices with each other. Now we are looking at weirder things. So neither of these are 2 by 2 matrices. They're not square matrices. You know, they have different numbers of rows and columns. And now that's what we're looking at. So let's dive straight into seeing how we do something like this. So the first thing that we should do is work out the dimensions of each matrix so that we can know whether we're even allowed to multiply these two, because it's not a given that you can multiply any two given matrices. You have to check that you can. So what's the dimension of the first matrix? Pause the video, have a think about what it will be. Okay, this is going to be a 2 by 3 matrix, because it has 2 rows and 3 columns. Okay, what about this one? Pause the video quickly. How many rows and columns does this one have? What would the dimension be? Well, 1, 2, 3 rows, 1, 2 columns, so it's a 3 by 2 matrix. So can we multiply them? Yes, we can, because the number of columns from the first matrix is equal to the number of rows from the second, which means yes, we can multiply them together. So we know that we're even, allowed to do it. That's a good start. Now, just to make sure that we don't make any mistakes, what should the dimension of the result matrix be? What should that be? What should the dimensions be? Well, that's going to be a 2 by 2 matrix, because the resulting matrix will have the same number of rows as from the first matrix and the same number of columns as from the second. Okay, now how do we actually times everything together? Well, just like always, we're going to times the first row by the first column, then the first row by the second column, then the second row by the first column, then the second row by the second column. Okay, and how exactly do we do that? We do it just like this. So 5 times 2 is 10. So I'm doing first row, first column, 5 times 2. Then I'm going to add minus 1 times 9. Okay, then I'm going to add 2 times 7. And that's the top left entry. Okay, and it's a 2 by 2 matrix. All right, top right entry is going to be the first row by the second column. So again, we're going to have a 5 times 2, which is 10. We're going to have a minus 1 times minus 3, which is plus 3. We're going to have a 2 times 4, which is 8. So that's the top right entrance. Okay, then bottom left, we're going to do 8 times 2, because this is the second row times the first column. So 8 times 2, that's 16, plus 3 times 9, which is 27, plus minus 4 times 7, which is minus 28. Okay, we're almost there. Bottom right, we're going to have the second row times the second column. So 8 times 2 is 16. 3 times minus 3 is minus 9. And finally, minus 4 times 4 is minus 16. So this is basically the answer. Obviously, we can simplify it, but that's pretty straightforward. So this is going to be 10 minus 9 is 1, plus 14 is 15. This is going to be 13 plus 8, which is 21. So this matrix times this matrix is this matrix. Okay, and one thing that I'll mention quickly is that, remember, if we were to swap the orders around of the matrices, would we be able to do that? No, we would not, because the number of columns of the first would no longer equal the number of rows of the second, because they would have swap places. So you cannot swap the orders of these two matrices. It will not work. You will not be able to do that. That is the first example. Okay guys, we have another example here. We're going to find AB, where A is the matrix 1, minus 2, 3, 4, and B is the matrix minus 3, 2. So one thing about this is the way that I personally like to write matrices. Sometimes you can label a matrix A, B, or whatever letter you want. And normally in a textbook, these will be bold letters. So it'll be a bold capital A and a bold capital B. Obviously when you're writing with either chalk or a pen or a pencil is pretty annoying and difficult to write things in bold, so people tend to underline them. So if you see A underlined like this, for me, in my videos, that's just the matrix A. Again, it would be in bold, but I'm not going to try and draw every single letter in bold because it takes too long. So if you see it underlined, it means it's in bold, right? It just means it is a matrix. That's all it means. That's my notation. A lot of people use that as well. So we want to find the matrix A times B, okay? And we get told what A and B are. So let's do that. So we are basically being asked to multiply the matrix 1, minus 2, 3, 4 with the matrix -3, 2, like that. Okay, again, let's make sure that we are actually allowed to do that by checking the dimensions of each one. So this is clearly a 2 by 2 matrix because it has 2 rows and 2 columns. And what do you think this will be? This is going to be a 2 by 1 matrix because it has 2 rows and only 1 column. Can we multiply them? Yes, we can, because the number of columns of the first is equal to the number of rows of the second. And what will the result be? It will be a 2 by 1 matrix because these are the outside numbers. So we're looking for a 2 by 1 matrix. Okay, so we're going to multiply the first row of the first matrix by the first column of the second. So we're going to do 1 multiplied by -3, which is -3, plus -2 multiplied by 2, which is -4. That will be the first entry. The second entry, remember, it's only a 2 by 1 matrix. So there's going to be one number here and one number below it, and that will be it. So it's just going to be directly below, and it's going to be the second row, but again, there's only one column, guys, for this matrix on the right. There's only one column, so it's just going to be the second row times the first column again. So it's going to be 3 times -3, which is -9, plus 4 times 2, which is 8. Okay, and this is going to simplify to be -7, -1. That's the answer. Okay, guys, that is the gist of multiplying matrices. We're going to end the video up with one more monster question. Okay, so we're, for the first time, going to multiply a 3 by 3 matrix with another 3 by 3. So hopefully it's clear to see that this is a 3 by 3 matrix here, 3 by 3, 3 rows, 3 columns, and same with this one. So can we multiply them? Yes, because you can multiply any 2 square matrices of the same dimension, because this number will always equal this number. What will the result be? It will be a 3 by 3 matrix. So we're looking for a 3 by 3 matrix. Okay, so let's just get straight into it because it's obviously a pretty crazy question. First row by first column. So 1 times -4 plus -1 times 9 plus 2 times 4. That's the top left entry. There's going to be 9 of these guys. First row, second column. 1 times -3, -1 times 1, 2 times -1. Okay. First row, third column. So it's going to be -8 plus 6 plus 14. Okay, we're a third of the way there already. All right, second row, first column. 3 times -4, that's -12. 1 times 9, so plus 9. And -6 times 4, -24. Okay, second row, second column. 3 times -3, -9. 1 times 1, plus 1. -6 times -1, plus 6. Okay, second row, third column. 3 times -8. 1 times -6. -6 times 7. Okay. Third row, first column. So you see we're just going through the rows, column, 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 row, column, 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 row, column, column, column. That's the idea. So third row, first column, 4 times -4, -16. -1 times 9, -9. 7 times 4, 28. Third row, second column, 4 times -3, -1 times 1, minus 1 times 7, or 7 times minus 1. Okay, and finally, third row, third column, last one. So 4 times minus 8 is minus 32. Minus 1 times minus 6 plus 6. And 7 times 7 plus 49. Okay, so I'm going to simplify this for you. You don't have to watch me do that. And that is the simplified version of the matrix. Okay, so it's a 3 by 3 matrix and it is right there. So hopefully, guys, you are somewhat comfortable now with multiplying any two matrices, as long as they can be multiplied, right? You've got to check that you can multiply them. But any two matrices that can be multiplied, hopefully you should be somewhat happy with how exactly you do it. If you're still unsure, the best way to learn how to do this is to open up a textbook, go on the internet, find some questions, and start trying some on your own. That's the single best way, just in general, for all of mathematics. The best way to learn is to do things, do practice questions, etc. Get you thinking, get you practicing, putting it on the page. But especially with something like this, it's very algorithmic, just practice. So just do loads of questions, all sorts of matrices, and before long, you will be an absolute beast of matrix multiplication. Thank you guys so much for watching, as always, and I'll see you in the next video.